Welcome to my YouTube channel. Please hit the subscription button and so that you can always get videos that I may post. So today we are going to solve a past paper which is October-November 2023 of Statistics 1 variant 5.1. So without wasting time, let's start right away. So there we are. So they are saying use your graph to find the interquartile range. How do we get the interquartile range? It is upper quartile minus lower quartile. Upper quartile is the median between 50 and 100, which is 75%, and lower quartile is the median between 0 and 50, which is 25%. So that's why when it comes to a cumulative graph, when we are looking for upper quartile, we say it is 3/4. So we shall say upper quartile, which is Q3. That's the notation which is usually used, which is 3/4 of n, and our n is 120. So we shall end up having 90. So come and go on your y-axis, look for 90, and then see. 90 is, you need to study your scale properly. It's on the 5th box, so I don't know. Let me see, 1, 2, 3. So they're right there. So meet your graph, and then read down, and you can see clearly that our upper quartile is 31. Then lower quartile, it is a quarter n, so it is a quarter of 120, which is basically 30. So we need to read 30. So you come to 30, it is not actually on the real line, it is around 23.6.7. So you could say 20, it is actually around 23, not 26, 23.7. So you could have said 23.8 because it is not exactly on the real line. So if you want the interquartile range, we shall say it is upper quartile minus lower quartile, which is 31 minus 23.7, and then you get your interquartile range. And you should know what actually the interquartile range gives you. The interquartile range tells you how varied the data set is. So now, without wasting time, when you try to subtract with your calculator, you end up having the interquartile range as 7.3. 7.3. So the interquartile range tells you how varied your data set is. So we go to part B. It says 35% of the children took longer than t seconds to complete the puzzle. So 35% took more. 35% took more. So 35% is around there. I'm just assuming this is 35%. So they assume it took t or more, meaning the other percentage, which is 65, took t or less. So it is very important for us to know 65% of 120, what it corresponds to, and that we shall be able to read our t. So what is 65% of 120? So you'll get your 65% of 120. Use your calculator properly, you'll get 78. So when you get 78, we need to now see the value of time 78 corresponds to. So if this is 60, this is 70, so 78 is right there, calm, reach there, and then read down. So you look for you go to 78 and move to the curve and see the value of time that it corresponds to, and clearly you can see that it is 28.5. So next, so we go to the next question. So look at the next question. Which topic is it from? So we are seeing that Hazim repeatedly throws two ordinarily fair six-sided dice at the same time. So there are how many? There are two fair dice that are thrown at the same time. And we are told that on each occasion the score is the sum of the two numbers that she obtains. So the question says find a probability that it takes exactly 5 throws of the two dice for Hazim to obtain a score of 8 or more. So now, according to this question, you need to know where this question is from. The fact that they are saying he threw or she threw the dice repeatedly, then we are told the question is phrased in the way that he gets what we want on the fifth throw. It means that this lady failed 4 times and then passed on the fifth throw, meaning the score of 8 or more was gotten on the fifth time. So this makes this question to be geometric. A geometric question. We are interested in getting the success for the first time, and we see clearly that here getting a score of 8 or more was gotten on the fifth row, meaning the first row failed, second we failed, third she failed, fourth failed, and then got what? The score on the fifth row. So it is a geometric question. So in the geometric question, probability of x equaling to 5. So this 5 is when the success happened, meaning failed 4 times and then on the fifth time got a success. So now we need to get P. What is P? If two dice are thrown, what's the probability of us getting the score of two? I mean, if two dice are thrown, what is the probability of getting a score of 8? And remember, we are told it is sum, meaning they were added up together. So I request that you always shortlist. Like you list them so that you can be able to tell how many gave you a score of 8 or more. So we have 2, 6, meaning if you have 2, 6, you automatically have 6, 2. If you have 3, 5, then another one could be 5, 3. Yeah, I'm looking at different arrangements. You can have that. And then if you look at 6, 3, then we can have 3, 6. Right? And then if I look at 4, 4, that is the only way. When I look at 4, 5, it means we can have 5, 4 as well. Make sure you don't repeat when you're in an exam. Be careful enough. Then when I look at 4, 6, have I written it already? No. So meaning I can also have 6, 4. You need to be really careful. 5, 3 I already have. 5, 4 I do. 5, 5. Not yet. Then 5, 6. Meaning I can also have 6, 5. And then let me see. Do I have 6, 5? Yes, I do. Then I have 6, 6. So try and see. So yeah, add them up. I don't think I've left out any. So you try to list those two numbers between 1 and 6 that can be added to get 8 or more, meaning you could get 8. When added, we could get 9, we could get 10, we could get 11, and the maximum is 12. So meaning the probability of getting a score of 8 is 15. So what is our sample space? We are told there are 2, so meaning it is 6 squared, which is 36. And you could go ahead and reduce this by, can I say by, we could reduce it by 3. If by 3 we get 5, by 3 we get 12. So the probability of getting a score of 8 or more, the sum being 8 or more, is that, meaning failure, you shall have 7 out of 12. So you just go and substitute. So probability of x equaling to 5, getting our success for the first time on the fifth row, is q, which is failure, 7 out of 12, and then to the power of 4, then times getting a success on the fifth row, which is 5 out of 12. So when you work it out, you'll be able to get your answer. And you need to be very careful with your accuracy. You make sure that when you're giving your answers, they are to three significant figures. So that's it. And then we go to part B. What does part B want? Part B says, find the probability that it takes no more than 4 throws. See, it is a geometric. So we are looking for probability of x less or equal to 4. So meaning either you can get it the first time, or you could get it the second time, meaning you failed, and then you get it. You could get it the third time, meaning you failed twice, and then got it, and then fourth time you failed 3 times. And yeah, so this is one way. Or alternative, so we already know our P and Q, so you just substitute. Or alternatively, you use this shortcut. If you have probability of x less or equal to r, it is simply 1 minus failure to the power of r. So you have to memorize this because it's not given in the formula booklet, or you could use this the other long way. And then, which is simply 1 minus failure. We see it is clearly 7 out of 12, and then to the power of 4. So this one here, you have to master it. So that, because it basically works, it only works for a geometric question. So meaning if they tell you less than 4, it means you should know that it is less or equal to 3. So you should know how to play along with the inequality sign to be able to answer questions concerning geometric. And when you work it out, you'll get your answer as 0.884. Yes, 2 3 significant figures. Pay much attention to your degree of accuracy. So then we go to part C. What does part C want? They are saying for 8 randomly chosen, for 8 randomly chosen throws of the 2 dice, find the probability that has obtained the score of 8 or more on fewer than 3 occasions. So here you need to know that they have given us the n. So they have given us n, but in the other questions we did not have n. So you need to know that this one now has changed from being, the question now has changed from being geometric to now to binomial. So we are interested in getting the score of 8 less than 3 times. Meaning we are looking at us having no score of 8 or more, then having it once, then twice. So you need to know that actually this is a binomial question. The P and Q do not change. P, it was, our P was actually 5 out of 12, and the Q was 7 out of 12. So the P and Q do not change. So yeah, you come and work it out. So you go, you open your formula booklet and look at the binomial expression. And so this is 8, 0, P, which is 5 out of 12. We are actually having no success, and then we are failing, meaning we are not getting a score at all in all the 8 rows. You need to know that. Then where we got 1, it means in all the 8 rows we succeeded once. And then it means we failed, 7 times. And then you go to where you got the score twice, meaning you got it 2 times and failed 6 times. So you work it out. For here, I see clearly when you put it in your calculator. For the first one where we get no score at all, you end up having 0.01341. Where we succeed once, we have 0.07661, and then where we succeed twice, we have 0.1915. And when you add all these up, you end up having 0.2882 as your answer. So we go to the next question. The next question is number 3. What is it saying? So a farmer sells eggs. The weight in grams of the eggs can be modeled by a normal distribution. So here you know that actually this question is about the normal, with mean 80.5, standard deviation 6.6. Eggs are classified as small, medium, or large according to their weight. A small egg weighs less than 76 grams, and 40% of the eggs are classified as medium. So they are saying find the percentage of eggs that are classified as small. So how do we get the percentage? If you have the probability of small, then you can multiply it by 100 and then get the percentage. So we already know that an egg to be classified as small, it has to be less than 76. So we shall say probability of x less than 76. We could standardize this value. So standardizing it, we shall have 76 minus the mean, which is 80.5. We divide by the standard deviation, which is 6.6. So we shall end up having our z. When you work it out, we have negative 0.6818. So now why do we now give it in 4? Why do we give it now in 4 decimal? Because we are working out, we are going to get the probabilities, so it is better you give your answers to 4 decimal, 4 decimal points. So now, we are looking for probability of z less than negative 0.6818. One thing you need to note is the normal table never reads a negative side. So flip it, just like the way you turn a page, and this shaded region will be to the right, and the normal table never reads to the right, so which is simply 1 minus area to the left, which is 0.6818, and I'll end up having 1 minus 0.7524, and you should be able to read this on your normal table, and then you end up having your answer as 0.2476. And the final answer, this is the probability of an egg being classified as as small. So if you want the percentage, you just have to multiply it with 100, and you end up having 24.8%. Then next, Find the least possible weight of an egg classified as large. So we want to know the least possible weight. So we already know the percentage for medium, which we were given as 40%. We know the percentage for small, which is 24. So when you add these plus 40%, and then you need plus the, of course, plus large, we should be able to get 100%. I first want to know the percentage of large, and when you work it out with your calculator, you should be able to get 35.2.24. So now this is when you have the percentage, it's like you have the probability. So probability of x, you know, of x greater than that large value, I end up getting 35.24 over 100, and it will give you it will give you 0.3524. So now remember, so this takes us reverse working when it comes to the normal table. You have the probability, so we need to read the z, which gives us the probability. But remember clearly that actually when you look at your normal table, those probabilities, we don't have anything which is less than 0.5. So to read the normal table, you need to get 1 minus 0.3524, and we end up having 0.6476. So we need to look through our normal table and see what gives us 0.647, which z gives us this value. And if you don't know, please, how to get it, you can comment so that I create a video on doing that. So this is the value which gives it to you, and yeah, and it is actually positive. So this is the z which gives you this. This is the z that gives you 0.647, and we see clearly that it is positive. Because if you're shading to the right and the area is so small, the area is 0.3524, it means it is positive. So it says in the right, it doesn't close to go to the negative, so it is positive. But remember clearly that this z, how do we get z? Z is basically x minus mean over standard deviation. So we already know this z, which is 0.378, meaning it is equal to that x that we don't know minus the mean, which is 80.5, then over 6.6, which is the standard deviation. And when you cross multiply, you end up having x equaling to 6.6, times 0.378 plus 80.5, and you end up having your x as 83 as your answer. Okay, so here this was about reverse working. You're already given the probability, and then you need to get the z that reads that probability. So yes. Then we go to C. So okay, C, what about C? See, they are saying 150 of the eggs for sale last week were weighed. What are they giving us here? They are giving us the N. So they're saying use an approximation. We only study one approximation in statistics 1, which is binomial to normal. It is normal approximation to binomial. We have a question which is binomial, meaning we know the N and P, but we answer it using normal. Why? And there are conditions for you to use that approximation. NP must be greater than 5 and NQ also must be greater than 5. So here we are told medium, and remember the probability of medium was 40% according to the question, which is 0.4. So we use that approximation, which is a normal approximation to binomial. It is a binomial question, but we answer it using normal. Why? Because binomial is discrete. The outcomes are counted, and then when it comes to normal, it is a continuous, where it is given in range and you can't get an exact value. So that's why you also consider changing the x, and this is what we call continuity correction. And the question says use an approximation to find the probability that more than 68 probability of x greater than 68. So this 68 is, we shouldn't take 68. So in continuity correction, we add 0.5 or subtract 0.5. So if they say greater than 68, it means 68 is not part. So it means the x for this case is I will take 68.5, because if they say greater, it means 68 is not part. So if I'm standardizing, the x I will use will be 68.5 minus mean over the standard deviation. Because the question was binomial, the mean I should use would be binomial, and also the standard deviation should be for binomial. So meaning, how do we find mean in binomial? It is NP. So it is simply 150 times 0.4. Then how do we get standard deviation? It is NPQ 150 times the P, which is 0.4, and then times the Q, which is 0.6, and you take a root, and you end up having, here when you get your calculator, you end up having 6C. Here when you take a root, you end up having 6. So in my Z, when standardizing, it is simply 68.5 minus the mean, which is 60, over the standard deviation, which is 6. So when you go ahead, you end up having your Z as 1.417. So we are looking for probability of Z greater, because look at this sign of greater. So greater than 1.417. A normal table never reads greater, so it is simply 1 minus area to the left. And when you read on your normal table, you end up having 0.9217. Yeah, so you should know how to read the normal table. If you don't know, please comment that you do not know, and then so that is the probability. So it was a binomial question because we had N and P, but we worked out using normal because of the conditions that NP is greater than 5 and NQ is greater than 5, and the fact that one was it was by discrete and another one continuous. That's why the x changes. All right, so that's it for this very question. That's it for that question.